quickly, we'll have to start shifting gears. What is the amplitude, phase, period, frequency of this sinusoid? We have 1, 2, 3, 4. Notice cosine of something is also a sinusoid. Okay. Quickly, what is the amplitude? What is the phase? And we typically use notation Vm, V max, okay, V peak. V peak. What is T? What is F? Some of these are very, very simple. Now, Dinesh Kumar has actually a slightly surprising answer. This is 12 over root 2. Okay. So there is some notational complication, minor complication. Okay. This function has a peak of 12. Okay. This is some cos function. It has a peak of 12. In practice, electrical engineers typically refer to RMS values. And even that would be 12 into root 2, not 12 by root 2, right? So, if you draw the function corresponding to this, okay, slightly shifted this way, its maximum is 12, right? So this is going to be 12. What is phi? Now this actually, phi is not that straightforward. Okay. Because you can write this as a sine, or you can keep this as a cos. And the angle here will change because there is a 90-degree difference between sine and cos. So which one should we use? Let's stick to cos for the time being, okay? That is, even if something is given as a sine, you have to convert that to a cos. And then look at the phase there. Phase is 10 degrees. And then time here, time period quickly. Notice omega is 50. Okay. This is 2 pi by t. So t is 2 pi by 50, pi by 25. And then frequency is 25 by pi. Okay, here itself, couple of difficulties are starting to show up, which are actually very, very important in from the perspective of even gate. That is, notice there is a difference between V peak, okay, and V RMS. When the function is given, okay, we can easily read the peak there. And then cos omega t plus phi, okay, sin omega t plus phi. So what is the phase? Say if you have been given this function instead of a cos, you have to convert that to a cosine and then only read the phase. Okay, phase is defined here. Phase is defined here. And again, RMS, we have kind of heard about it in high school and all that. Some of us know what it is, some of us kind of forget. We'll come back to this when we look at, AC circuits, not just sinusoidal circuit, but AC circuits. Okay. So for now, we'll be mostly working with V peak. So there is a shortcut here. Okay. That shortcut is that the function that has zero phase is cos. Okay. Phase is defined here, or, cos has zero phase. Cos omega t has zero phase. Omega t has zero phase. Sin omega t has non-zero phase. Even though it's just sin omega t, there is no plus something, it has non-zero phase. And a quick way to remember that is notice the zero phase, zero angle is written along x-axis that corresponds to cos. Okay, the angle is always measured like this. This is positive angle, positive phase. That is counterclockwise. This is again is convention. And notice, in order for the mat to be consistent, our sine, if it is aligned along the vertical axis, this is almost like a mnemonic. Okay, don't think of complex plane and all that. If a cosine is along this direction, sine is almost perpendicular to it. Okay, we can quickly start seeing all relations over here. For example, take cos omega t, okay, minus 90 degrees. Automatically, what you get is sine omega t. Or the other way around, take sine omega t. If we add plus 90 degrees, you get cos, right? So what you need to remember is this x-axis is cos omega t in this mnemonic, let's say, and this downward axis is sine omega t. Okay, in that way, or we can get all our relations over here. Let me write few more relations. So what is sine plus or minus 180 degrees? So this mnemonic actually works very well. Okay, so if this is plus sine omega t, what we have here is minus sine omega t. Okay, and we can start seeing all the results. You take sine omega t, you add, that is go in the clockwise direction or counterclockwise direction. So either plus or minus 180 degrees, what you get is minus sine omega t. Almost like a mnemonic for the formulas that we have learned. So we can actually start seeing every other result. Let me again refresh this page. Okay, so quickly, what is sine omega t plus 90? Can we answer that? What is this? And then what is cos omega t plus or minus 180 degrees? Let me label this. Let's say this is 1, this is 2. If you take the sine curve, okay, at least by this mnemonic, if we add 90 degrees, you get cos omega t. You can verify all these expressions, using the standard identities. And then notice, if you take cos omega t, either go this way or that way 180 degrees, what you end up with is minus cos omega t. Okay, the negative direction. So minus cos omega t. And the reason to choose this as x-axis and the negative y-axis as sine omega t has to boil down to one reason. Okay, the curve that has zero phase, again let me refresh the page. Okay, the curve that actually has the peak here and kinda comes here, touches, and then goes right. Notice that function is a cos function. It has its peak exactly here. Notice the dotted curve has a peak slightly to the right of this axis, right? The peak is exactly there. That function is cos omega t. That function by convention has zero phase. So when we are trying to understand phase, having cos omega t in the x-axis and sine omega t in the y-axis, we'll keep all our mathematical relations intact. And this is, of course, by convention. So the question is now, if we have, notice two independent things, that is two things that perpendicular, we can start talking about combinations of all those things. Right? We can also have, we have phases in between the cos and sine curves. We can also start talking about them. Okay, and which is where all the complex number relations are very, very useful. Okay, can we quickly write down the function corresponding to this, the arrow pointed over here? Notice that is c cos omega t minus theta, and also you could quickly see that is square root of a square plus b square. C is the hypotenuse. Okay, cos omega t minus theta. And if you use cos A minus B relation, you could also start seeing that as a combination of a cos omega t and sin omega t. Okay, you can expand this further knowing the relations that we have, and you can see that it's actually a combination of a cos and omega. Fine. So for now, the mnemonic is the most important, and let's take that. And similarly, if any vector is given here, we can easily write that as as a as a function, as a sinusoid. In this vector, particularly notice has a magnitude of 5. Okay, take cos omega t. Okay, add a phase of 53 degrees. In fact, here you should be able to write this as a cos omega t plus b sin omega t. Okay, this is what I meant by combination of a sin and omega. You can go check the math uh, using cos a minus b formula. It should be hold good. Theta should be minus tan inverse of b by a.